Hi everyone, my name is Romain Nugou, or Romain. I'm a full stack developer at Evolving Web. I've been a full stack developer for more than 10 years, and today we're going to talk about how to build a scalable data-driven application. It's not a Drupal specific presentation, it's going to be based on React, but it can work with pretty much any framework. Yeah.
So you're going to show how to do scalable apps with React, just in general?
Yeah.
Okay, yeah, because I actually have an app that I work on that actually connects to Drupal interface.
Okay.
Yeah, so, all right. So this might be interesting for me.
Yeah, sure. Yeah, so it's going to be based on React, but it can work with Drupal, with any framework, any CMS. So, yeah. So before I'm going to talk about how to build scalable data-driven application, I'm going to let my colleague give you more context about the client and the project this use case is based on. So you can go, Andre.
Yeah. So hi, I'm Andre, and I was lucky to be a part of this project as a project manager, and I'm excited to share this project with you. But before Roman gonna dive into the deep architecture, and believe me, he will. I just want to zoom out to show you a main picture to understand better how it was approached and what was the things we achieved. So here we're gonna start with the context, explain the challenges we faced, and Roman will walk you through the architecture behind the solution. So today we will share how we approach building a scalable data exploration platform for the Grid project. And you might ask, what is the Grid about? So Grid is an open international database that provides harmonized statistics on income inequality and income dynamics across multiple platforms. And to explain about it, so we have our client. The approach to us, it's a group of researchers and scientists across the world with the co-directors from the different universities. We have Fatih University from Toronto, Luigi from Stanford University, and Gianluca, Princeton University. So he works here. And from this point, from their website, there is an option you can find the statistics. It's a current website, and they have download app where you're able to find some right stats with the countries, with the different choices, and proceed to download, and you're getting kind of very nice organized set of data, and not everybody kind of will understand what is going on here. And this is going to be kind of the goal, to build a new data exploration app that allows researchers to navigate complex data sets in the intuitive mode. So what we have here, multiple visualization models, clear and intuitive data exploration, and high performance with the large data sets. So we did a benchmarking exercise to analyze existing data visualization solutions, identify best practices, and inform the design decision for our own data visualization project. So here you can see one of the examples. It's a world inequality database. And one more we found very interesting. It's a Federal Reserve Bank of St. Louis. And our current client as well, it's a climate data of Canada. And you can see their interactions already exist. So moving forward, the challenge. So this is the most interesting part. At this point, we realized we weren't just building charts. We were designing a system capable of handling millions of possible data combinations. And let me ask you a question, the math problem. What if I give you 300 plus statistics, 26 countries, and more is coming? So 3 gender options, male, female, and combined. 5 age groups option, 50 years data, and 3 visualization models. So a little pause. What do you think? How many possible views we're gonna get?
999.
999 plus. Indefinite. So definitely the right question, the right answer is it's definitely less than we would like to hard code, and me as a PM less than I want to manage in the spreadsheet. So kind of challenge the typical timeline, what we're facing. Okay, at the beginning, like quick MVP, let's build something quick. What we're facing, 10 stats, hard-coded logic, everyone's happy. Code is messy, but we'll refactor it. Next one, growth. Okay, we're gonna add 50 more stats. And what we are facing, copy-pasted code everywhere, first bugs, nice. Should we refactor? No, we have a deadlines. And project manager is sitting on us. So complexity. Added 240 remaining stats and some new features. Now team velocity drops. Every change breaks something. We need to rebuild this. So many data applications start simple and then complexity catch up. So what we need? So what we want. So like we had a clear list of what we wanted. So maintainability, scalability, reusability, and performance, and pretty clear list of what we wanted to avoid. So it's a code duplications, rigid structured, performance bottlenecks, and the real question was, how do you actually design a system that achieves all of this? And that is the part where I'm gonna be happy to pass it to Roman, and he's gonna dive to the real stuff, architecture. So, please go ahead.
Yeah, so first, let's do a quick exercise. Let's say we want a quick POC or prototype. So our goal would be to turn our CSV data files into a beautiful line chart. So as we are in 2026, let's use AI. So let's try to vibe code a prototype of that. So first, we need to init our React application. So let's say we have like this simple prompt, create a new React application using Vite with TypeScript and iChart library. iChart library is the JavaScript library that we're gonna use to display, to render the chart. So then you have like instantly like this application. So that's basic, that's just a React application. Second step, let's format our data. So that's our data. It's come into a lot of CSV files with a lot of columns and a lot of values in it. So once again, we're gonna ask AI, it can be Claude, Gemini, whatever, to turn this into a JSON file that our React application will be able to read. So our prompt could be create a JavaScript script that will read my CSV file and generate a JSON file that React app will easily read and use. That's it. We have our JSON files. So we're gonna be able to use this data into our React application. And the third step would be create our chat component. So once again, a short prompt, now create a React component that would read my JSON data file and render a line chart using iChart library. Once again, it's quite straightforward. We're gonna end up with this kind of component that's simple, that's usable, and here's the result we're gonna have. So everything works. We are happy. We can visualize our data, and it worked with 136. So why not doing that 300 times? No, not a good idea.
But it's so easy.
Yeah, but you don't want to do that. So that's where I'm going to speak about our solution. What if those economic statistics could describe themselves? So in other words, what if we stop telling the app what to do and let the data tell the app what it needs? So yeah, so that's the quite basic idea we had. And so basically it means like build for the ensemble and not a statistic at a time. Think in terms of patterns. So see if like some statistics can be grouped, so they can be plotted together, and then build a flexible and modular structure that can grow. That means think about the scalability from the start. So then that's where we came up with those three pillars, which are actually steps. So first we would have like the data file. So let's say it's just the description of the statistics. So for example, I'm a share top 10% statistics. Then we would have the second step, which is how. So that's the smart system we want to build, and that will get what it get from the data files, and it will tell the application, this is a time series statistics, it needs a map and this control, for example. And then we will have the third step, which is the display, so the user interface, and it's gonna get and take what comes from the second step and render the controls and render the chart. Yeah.
Hi. I'm sorry. I'm trying to figure out what is exactly share top 10% statistic?
It's just an example of a statistic.
But what is share?
This statistics is that those are economic data, and so it's gonna tell us what percentage of the wealth does the top 10% of the richest people.
Right.
So we have that for the top 10%, 1%, 0.1, 50, or bottom 50%. So we can then compare between those kind of share. So
Okay,
yeah.
So that if I understood correctly, sorry to interrupt, but so the first thing is enumerate all the different statistics. Then second is for each one, enumerate the metadata that is relevant to them, that affects how they're presented. And then third is create a display logic for them and their specific properties. Okay.
Yeah, and those three steps can be like said with those technical words. First, we're gonna have the configuration. So it's gonna be a config first design. So we're gonna have like a huge config file, just data, no logic in there. Then we're gonna have the smart system, which is gonna be self-describing object. So we're gonna have like a class hierarchy with polymorphism and a lot of like how many variation we need to render those statistics. And then we're gonna have the dynamics UI that's gonna use the factory pattern to maintain this consistent instantiation. And I'm gonna explain that later. But so that's our flow. So we're gonna have configuration, then the classes with factory, then the dynamic UI, which is gonna give us this beautiful application. So before diving into the more complex part, I'm gonna give you like a short demonstration of what we can okay. Yeah. So, where is? Oh, no. I can't. Okay, so let me grab this. Go there. So here are our applications. So for example, you can see we have like this beautiful map chart. We can switch to other view mode. So we have this kind of chart, which is a line chart. So for example, I was talking about the share top 10%. So that's this one. So you can see that, for example, in 20,000, the top 10% owns 35% of the income share. And then you can compare it to the top 1%. So you can see for sure the top 10% own more than the top 1%. But then you can also share it with compare it to the share bottom. So you can do stuff like that in this line chart. Then we also have this third view mode, which is bar charts. So that's another kind of way to visualize the data. The line chart was across time, so you can see the evolution of these values. The bar chart is more if you want to see like compare other gender, other age groups, so you can do that from the bar chart. And so these are like kind of statistics group, and there you have all of our statistics. So that's how it works. It's still work in progress. It's not the final design, but pretty much every features are there. So that's it for the demo. So you can come back to the presentation. Yeah, why don't I? Okay. Oh, I'm sorry. Okay, anyway. So here's for demo. So now let's dive to all of the concepts I was talking earlier. So first, let's talk about our tech stack. So we have React and TypeScript. We are using TypeScript for obvious reason because it's strongly typed, because it catches a lot of error before runtime, because it's more readable and maintainable. So a lot of various reasons. So yeah, sorry. Oh, no. We are also using Vite, and the library we are using for the data visualization is iChart. Then for the styling and UI, we are using Tailwind4's ChartCN UI, which is using Radix UI. And then we are using some testing framework. We are using Vite test with React testing framework, and for the unit testing, sorry. And then we are using Playwright for the automated end-to-end tests, which are really convenient when you have like a small team and you want to catch like end-to-end errors before going live or going like in any test environments. It's like automated, like in a GitLab pipeline, and it works great. So that's it for the tech spec. So now let's speak about the first part of our architecture, which is the configuration. So just think of it as a profile card. So in this JSON file, you have every info about the statistics. So you have for sure its ID, that's how we're gonna identify it. We have its name, short name, and then we have what we can call its personality, which is in our config file, the class. So that's the class this statistics is going to use to be instantiated and rendered later in the application, and that's going to help us render the UI. So, oh no, I'm not on the one. So we currently have more than 300 statistics in our config files. So all of them are like a JSON object, and yeah, so that's how the config file works. Then first, let's speak about what is polymorphism. So think of it as think of it as like an idea that's the idea of different things can respond to the same instruction, but in their own way. So basically, it's same action, different results. So here's a real life example. So for example, if you're gonna ask to any animals to speak, it doesn't gonna respond in the same way. So that's how polymorphism works. So different objects can respond to the same action in their own way. Then you have, so that's our class hierarchy. So at the top of it, we have the interface. So that's kind of the contract. So an interface in programming language, it's just the list of methods that's the class that's gonna inherit it needs to define. So then you're gonna have the base class, and then you're gonna have all of those of the specific class we're gonna need for our statistics. So for example, time series class, density class, mobility class. So all of those are going to inherit from the base class. And each class can behave differently. So that's the contract. As I said, that's the interface. So I said it works like as a contract, and that's this that enables polymorphism. So it's just like a list of methods that every class needs to define. Then, we're gonna have like the base class. So it reads it reads from the config file, and so we're gonna use mostly to define the default values of statistic property, because not all of the properties are defined in the config file, because it would be redundant. So that's the config, the base class, and then we're gonna have like the specific classes that are gonna inherit from the base class, and that's where we're gonna have the opportunity to override the base class method. So that's polymorphism. So same question, different answer. So now before speaking about the third part,
So if you go back a slide.
Sure.
So this is super helpful for me. So you said speak, and then dogs say bark, and cats say meow. So same action, same label, but different behavior. So here the speak equivalent is get view mode, is that right?
Yeah.
And then the time series statistics class can speak map line bar, and the density statistics.
Yeah. This code means that you can define different list of view mode depending of which class you are going to use. So, for example, for the time series, we're going to enable map, line, and bar charts. But for density statistics, we're just going to enable line charts. Yeah?
How many such polymorphic, I guess you call it actions, do you have?
I'm sorry, what?
I'm sorry to get the terminology wrong. How many methods like this that you have, that different subclasses implement differently? Just to get a sense of.
Oh, we like in the interface we define maybe 30 methods, and then not all of those are overridden in the specific class. We're gonna override only the one we need to change from the default behavior.
So how many subclasses do you have?
Around 10 for now. 10. Yeah.
And typically, all 30 might be overridden. I mean, that's why they're overridden.
Yeah, all of them. Maybe not, because we have like basic methods like get ID, get names, and all of those cannot be overridden because all of those property are specific to each statistics. But most of them can be overridden. Yeah.
Okay, thank you. Oh, sorry. Yeah. Do you have multiple levels, like time series and then special time series statistics class, or do you have only one?
Yeah. As I showed over there, it can be infinite. Like it's not restricted to 1 or 2 levels. It can go below. And yeah, we do have some, because let's say for a group of statistics we need to change one parameter, and then but in this group we need to have like 2 subgroups to define another parameter. Then we're gonna have like this kind of hierarchy, or where we're gonna have like 2 other time series classes below that can.
Thank you. I know you covered this, but it's just fast enough that I was having trouble following.
Oh yeah.
And then you said it was 10 of these, or 10 somethings, and there's a lot more.
No, we have maybe 10, 12 of these for now.
Including the sum.
Yeah.
Okay.
Yeah. We need a little bit 10 or 12 for our 336 for now. Yeah, but it can still be like improved. We can like add on the other classes if we need. It's like flexible. So yeah. So next one for the before entering into the third part, what is a factory design system pattern? So basically, the factory is a class responsible for creating objects. So let's think about like a coffee machine. So a coffee machine gonna owns the recipes and gonna like be able to make any kind of coffee you want. And so an espresso, a latte, a cappuccino, all of those are different, but can come from the same machine. So that's how a factory works. So it's centralized object creation. It can simplify complex in it. Everything is gonna be gonna go through this factory. You're gonna have the factory which class you want. It's gonna give it to you, and it makes for sure codes easier to maintain, read, extend, etc. So our factory worked that way. So we have 2 steps. First, it's the registration. So we're gonna tell the we're gonna tell the factory which classes do we have. So it's you're gonna create like a directory of classes we have. So for example, we have the static classes, but then we're gonna have all of those 10 or 12 specific classes, and then we're gonna have the production step. So the production step, all the production flow is first we're gonna read the config. We're gonna find the class name. So that's where that's what I showed you earlier. And then you're gonna create an instance of the class the statistics need, and then return this ready-to-use instance. So here you can see in the constructor we have the registration, and then we're gonna have like a get method to return the instance we need for the statistics we want to visualize. So then finally we have what we can call the payoff. So it's kind of a auto-generated UI. So the user gonna select, like, for example, share first quantile. So it's a specific statistics we have. Then the app's gonna create the class instance. The class is gonna generate its control. So in the I'm gonna show you later, but in the class we have like some methods to list all the controls we're gonna need, and then the UIs will render automatically. So basically we select a statistics, and then we're gonna have the result, which is the map chart. And so that's what I just talked about. The class generates the control. For example, in our application, we have control at the top of the screen and at the on the right side. And so we have 2 methods for that in the class. So for example, the get sidebar controlled and the get top navs controlled. So all that's gonna return what the UI needs to render, and this way it's automated. We don't have any hard-coded drop-down in the application. We don't have any edge cases to handle. It's all handled in the classes. I just show you. So that's why I said it's auto-generated.
Sorry.
Yeah.
Can I see that beautiful thing? Yeah, that.
So something changes in the top bar based on the selection of the statistic? Is that what you're saying?
Yeah, actually it does. If I show you, for example, if I go back to the example, if I select, for example, if I go to density. So density, we don't have a chart yet, and we only have the show legend, which shows enable disable the legend. But if I select the statistics, we're gonna have another control over there. which is show normal. So it's specific to this kind of statistics. So for the density block, we may want to compare the actual value to a normal chart. So that's specific control for this statistics.
And sorry, there's a dependency between the statistics and the left sidebar as well?
I'm sorry?
Is the left sidebar dependent on the statistic?
Left side? Yeah. It depends more on the view mode. For example, the countries list for the one map, it's like kind of disabled because we want to show every countries. But also for some statistics, we are not gonna having like the same data. For example, we don't have the data for a specific statistics for every country, so those countries are going to be disabled if we don't have data. So we have stuff like that. Yeah.
Okay. So on the left is the list of all your statistics and then metadata. Then on the top we have sub-statistics related to those data sets. Then when you choose a statistic, you get to like that. Can we go back to your flow chart now? That shows like the two. No, like in your slide.
Oh yeah.
The next one. Yeah. So where are the sidebar controls per statistics and stats, gender, age?
For example, we like for depending on the statistics and the view mode, we're not gonna have the same list of controls. So like another example would be here we have the line chart, but if we switch to the bar chart, there we're gonna have another statistics where we can just change the x-axis population. So for example, we can go to gender and we can go to age group, and then we can add some. Okay, there's a limitation, but you can have something like that. So age group, if I add another age group, we're gonna have something like that. So
all of those 5 billion combinations are encapsulated in these various drop downs and checkboxes.
Yeah. It's fine. Yeah. So. Okay, so that's for the payoff. Let's speak about real world benefits. So we have 3. So first is better for scalability. For example, now we have more than 300 statistics, and if we want to add some other statistics, it's gonna be quite straightforward. We're gonna add those to the config files. For example, we want to add 10 statistics. It's going to be 10 new objects in the JSON file, and then we're gonna have to test our solution. We can use our automatic tests, and it's gonna be done. If we need some new kind of statistics, we're gonna be able to add new class to our hierarchy. So we are not gonna change what's already existing in our code. We can just add another class that will inherit from the bath class or another class if we want, and that's how it's gonna work. If we need another kind of chart, we're gonna add a new view mode, and we're gonna add a new specific chart component, and that's it. We are not gonna edit what's already existing. So that's for scalability. Better maintainability. Like I said, if we need to fix something for, let's say, time series, we are just going to fix that in the time series class. We are not going to have to change or fix anything elsewhere. So if we need to fix something in the line chart, we're going to fix it in the line chart component. And so each part is kind of like encapsulated, so each element is pretty much independent, so we're not going to break anything each time we want to edit something. So that's for maintainability, and then it's AI friendly. As you guys know, AI love redundant pattern, love having example to work on and to get inspired. So if you need to add new statistics, you can ask AI. If you need a new chart component, you can ask AI, just create me, I don't know, a round or round chart statistics, chart component. It's gonna look what's existing, and it's gonna have a lot of example in our code, and it's gonna be quite straightforward to it, and once again, it won't break anything. So now some lessons and takeaways. So when do we need this kind of architecture? So it would be a good fit when it's data-driven application. So for sure. So yeah, it's gonna be a good fit when we have many similar entities and variation. It's gonna be a good fit too when we want horizontal scaling, when we want to add statistics, when we want to add statistics group, whatever. So we're gonna just scale horizontally. So good for repetitive patterns, and for sure for long-term maintenance, because it's good for long-term because you're gonna have maybe more work at the beginning to create this architecture, but then you're gonna gain a lot of time when you want to like update it, maintain it, fix it, whatever. And so yeah, it's more long-term architecture. And for sure it's going to be overkill when you just want a simple or fixed UI. If you want just one chart, one statistics, 2, 10, whatever, it's not going to be a good fit for that. And it's for sure not going to be a good fit for POC, MVP, or prototypes. So that's it for the when to use this architecture. And finally, let's speak about some key principles. So it's a config first architecture, so the data drive behavior, polymorphism over conditional, use classes instead of if else, way more readable, maintainable, everything you want. Interface design, so that's base of polymorphism, so it define the contract, define what the classes needs to do, needs to have, and then implement. And finally, the factory pattern for consistency. So we have like a central registration point. Everything is go through the factory. Everything is controlled and is rendered by the factory. And so yeah, so that's it for consistency. Any question? Yeah.
About the JSON,
Mm-hmm.
2 questions. One, was your original data in a SQL database or CSVs and you converted it to JSON, or was it native JSON?
No, actually, we worked from CSV files. Andre spoke about what the client already had. It just have a download application. But it's maintained by someone else, by the University of Minnesota, so we don't have access to this database. And as the data isn't often updated, it's updated at most once a year, we have like those data into like in CSV file, and when we build the application, we run a generation script that's gonna build the JSON, the optimized JSON data files that we are gonna read in the application.
The second related question is, do you have a single master JSON data file that you always load into the app? You're not making any subsequent network calls to fetch more data?
No, yeah, we have like the config JSON files, and then we have the data JSON files. Yeah.
Sorry, just to clarify, each statistic, 300 of them, have a different JSON file.
Yeah.
And when you choose the stats picker, you download a new JSON file at that moment.
Yeah, and it's even more divided than that. We have like a JSON data file for each statistics for each country. So we don't load everything at the same time. For example, when we need to, if we're, let's say we're over there, we just need like the data for these statistics for the US. We don't load the data for every country at the same time because
So
we
you
don't need it.
drop the data every time you do a reload?
Yeah.
Okay.
we have like a cache system that's gonna like with like limited space, and we gonna use stuff like that. And our data is like optimized as, because every value you see there is real. For example, this 2.39 is for one country, one gender, and one age group. So we have like those subpopulation, and we don't duplicate this data in our JSON data file. We have like this kind of structure where it's yeah, I can show you if you want. It's that's, I don't know if I can't. If I go mirror, yeah. So that's how our JSON data works. So we have like the name of the statistics, we have the list of gender we have, then we have the list of age where it's available, then the list of year, and then after that but we have the value itself. So those are the value, and so this way the data isn't like duplicated, and we have like a smart system that's going to retrieve the data for each subpopulation. So we this way we know how to find a specific value for a country, a gender, an age group, and etc. Yeah.
You mentioned, you were able to encapsulate from the underlying high charts component widget to your own class, right, for each of these widgets or visualizations. Does that imply that the system that you wrote is charting library neutral, and perhaps you could even mix and match different charting libraries as necessary?
Yeah, because as I said, every component is independent. So we have like a React component that's gonna handle the chart rendering. So in this component, in the line chart component, it's gonna use iChart libraries. So it's in this component that we have the iChart configuration. So if we want to use tomorrow another JavaScript library, we just have to rewrite those components specifically. We just have to work on those chart components. So we don't have to touch to all of those classes I showed you. We don't have to edit the configuration or whatever. Just the components you need to update.
So what you're showing us looks like a full web page.
Mm-hmm.
If you wanted to embed that functionality into an existing web page, how hard would it be to refactor, like the positioning of the various filters?
Not that hard. If I want, I can disable like any component in the layout. If you want to get rid of the sidebar, I can do it. If you want to get rid of any other part of the layout, it's possible too. Like each part is independent. We have like the main React component that's gonna call each zone if we want, and each zone is gonna use the class the class instance the factory would have gave us, and it's gonna call the right method to have the list of components of control. So we can have like another layout if we want. We can yeah. What time? Any other question? No?
Thank you.
Thank you.